I am going to show you how much NMR sample you need to make for analysis. And a typical NMR sample would need between 5 to 25 milligrams. So that's at most 0.025 grams. So here is a sample, and this is the product from a BIBENZYL NBS experiment. And I just want to take a little, it should be just a little scoop four should be in that range. So I just want to show you how that looks, and I'll tile this label. Just take a little scoopful like this. This is how it looks. And let's see how much it weighs. Okay, so that's 0.014 grams or 14 milligrams. So the range was 5 to 25 milligrams. So that's in the range. So your scoopful can be a little bit higher or a little bit less than what we had, or even a little bit more is fine. So that's just, you don't have to weigh each time you need to make an NMR sample. You just kind of need to visualize how much to put in. And also for reference, you put about a little over 1/2 ml in the NMR tube, which I will show you. It's probably around 0.6 to 0.7 mils. So this is about 5 to 25 milligrams per like 0.6 mils. So when you're making up the sample, you would need to take that into effect. So if you're making like a 10 millimeter sample to stir it in before, then you would it will be like 25 times 10, so about 250 milligrams. Now we need to prepare our sample for NMR. So this is our NMR tube, and we have a pasteur pipette, our sample, our solvent to dissolve our sample in. In this case, it is dimethyl deuterated or dimethyl sulfoxide. And then we're gonna have to dissolve it first in a little vial, and we may or may not need the spin vane, but it's here just in case. And then for this sample, it doesn't readily dissolve in dimethyl, but it dissolves in the solvent better than other solvents. So we're going to heat it slightly to get it to dissolve on this hot plate here. Alright, so this is what we weighed out previously. Is about one scoopful, about 14 or 15 milligrams. So this is a 3 ml conical vial, and I'm probably going to fill it up to the 2 ml mark. So I'm probably going to try and put this in and then another scoop, because that 14 milligrams is for 0.6 mils. So this is more than double that, so I have to add a little bit more to make the sample. So on the NMR tube, and there's a standard I'll show you, we want to fill it to about this high, which is where the 0.6, 0.7 milliliters is. Alright, so I'm going to add my product first in here. Okay, and I need to add a little bit more. this. Alright. So for the DMSO deuterated, I'm going to use a clean, unused pasteur pipette because I don't want to contaminate the bottle. I'm just going to fill it. I might have to get another one. Let me get another one because I didn't fill it quite to the 2-minute mark. So I'm going to cap this. And I'll be right back. Okay, so here's my new pasteur pipette. Oh, shoot. I put the lid on, that's fine. So let me add to the 2-minute mark. Hopefully this will be enough. Oh, there's a little bit more, so let me get one more pasteur pipette. Okay, so here's a new one, and let me just fill it up. There we go. Okay. And then I'm going to loosely cap this. Actually, I'm going to invert it first. A little bit. It might be a good idea to have a couple pasteur pipettes ready, so you don't have to go back and forth. Alright, so I'm going to just sit up a little and gently heat it. Alright, so we just started heating it, and the reason why we want to keep this capped a little bit is because DMSO absorbs moisture in the air very readily. So in our NMR spec we might see a peak for water, a big peak. So, and that's fine, so we kind of want to try and minimize it, so we kind of cap it so we don't get much moisture in the vial. Okay, once in a while I'm going to invert it. Okay, loosen it up. So it's been a little over 2 minutes now. It's just starting to heat up. Let me invert it again. Okay. Actually, I'm going to add the spin vane to it because that might help it a little bit. Oops, bring this. And I'll put this in here. And I'm just going to start the stir. There we go. So we're about 5.5 minutes into stirring and heating. Let me just invert this. Okay. I'm going to turn the heat up just a little bit. It was on 55, now I'm turning it up to about 60. There you go. So we're about 8 minutes in, and let's see how this is looking. So it's starting to dissolve. It's not in one clump on the bottom, so I'm going to invert it again. So let's set it to stir for a couple minutes, and I'm going to heat up to about 65. Alright, so let me invert it again. So I'm just going to get a 5 ml conical vial ready in case this doesn't start dissolving more, because I'll just transfer into a 5 ml conical vial and then add more of the DMSO to help it dissolve. So I see the solution is starting to bubble or boil a little bit, so that's good. Let me invert it. And I have my 5 ml conical vial ready in case I decide to put it in there. So I'm just going to transfer this mixture in a bigger vial, 5 ml conical vial, to get it to dissolve better, and I'll add more deuterated DMSO to it. So I can use the same cap. I'm just going to put actually, let me just try heating it like this, because I know there's some residue left in here, but that might be okay because it might be too much of solid. So let's see if this dissolves good. Maybe I just don't need to add more solvent. Okay, so it's been about 6 minutes. Let me see if it's dissolving. I'm just going to add a little more due to the DMSO. Okay. Just a little bit. So I have my new pasture coconut. I'm just going to add some more to my sample. So let's see if that helps yet. Like this. I'm just going to invert this. Nice, let me invert that. It's getting there. So I'm actually going to turn the heat up just a little bit. There's that. About 80 degrees Celsius. Okay. Alright, so let's see if it's all dissolved. I'm pretty sure it is. So I don't see any solid in there. So I am going to put my sample in my NMR tube. So we need a height around this high, and it's about one good squeeze of this. Alright, so let me get the cap on. That actually looks like too much, so I'm going to take some out. And these tubes have a really small diameter, so they don't come out on their own. Let's see. Okay, so that looks better. This back in here. And then let's go and compare it to the standard on the reagent hood, or on the reagent hood. Got this. So here I am at the reagent hood, and I'm going to compare our NMR sample to the standard. So that looks about right. And it's okay if it's a little bit higher or a little bit lower, but we want it to be about this high. So now we just have to put it on our NMR rack for the class and submit it for analysis. Alright, so this is an NMR rack, and there should be one per room. And as you can tell, we label it per section and the TA and the course. So, and then the slots are also numbered. So your iPad number corresponds to one of these numbers here, and that's how the lab staff knows which NMR file to send to which students on campus. So this is our finished sample, and I'm just going to put a number 32. Say your iPad number is 32. And that's all we need to do. A staff member will process in the instrument room using a 600 megahertz or 400 megahertz NMR. And then you should analyze your results within less than a week.